Good Friday morning, everyone, and welcome to another wonderful end of the week Friday class. Like we always do every morning, we like to start off our mornings off with reading, and let's go ahead and get our reading started off. This week, I think you guys saw it there, is how to make a comic book or how a comic book is made. I know many of us are into comic books or into graphic novels. This kind of gives you a kind of an introspective look at how comic books are actually made. So let's take a look here. So how a comic book is made. How a comic book is made. There, you can see here are the table of contents. Looks like to be 6 total steps in how a comic book is made. So comic books, people love to read them. Kids like them. Adults do too. Question, what does it take to make a comic book? Answer, a whole team of people. Each person has an important job. The editor is the leader of the team. She makes the decisions about the story and the pictures. The writer thinks up the story and writes it. The pencil drawer draws the pictures to tell a story. The inker adds detail to the pictures. The colorist adds color to the pictures, and the letterer adds all the words in the picture. That is a big team. Step 1, the idea. Every comic book comes with an idea. The writer and the editor work together to come up with a good idea. We want to make a new comic book. A funny one or a serious one? An exciting one and with a new superhero. Any ideas? Yes. Muscle Girl, she's super strong. Sorry, we already have too many super strong superheroes. Mothman, he flies like a moth. He swats bad guys. He swats bad guys with his wings. Mothman has an enemy. It's the human light bulb. That's funny. Do you have any other ideas? Okay, how about Tiny Man? He can shrink the size of an ant or smaller. Tell me more. Wouldn't that be Ant-Man? He can go places that no one else can. He finds clues and he solves crimes. I like this idea. In the first story, Tiny Man stops a gang of bank robbers. Step 2. Oh wait, that sounds like a great idea. Our new comic book man would be Tiny Man. Step 2. Now the writer starts to work on a script. The script tells everything. The script describes the characters, and the script tells what the characters say. Tiny Man wears blue. He has a letter T on his chest. Oh, bank robber. Oh no, it's Tiny Man. The script tells the story in a comic book, and the story is told in panels. Panels are the boxes that you see at the top of each page of a comic book. The script tells the characters what to do and what to say in each panel. Panel 1, top panel. Inside the bank, the worker is behind the counter. There's a vase of flowers on the counter. The Tiny Man is hiding behind the flowers. He is speaking to the worker. Tiny Man, don't look at me when the robbers come in. I want to look surprised. It's not a problem. You're so small they'll never see you. Everyone in a comic book will use the script to do their jobs. First, the editor checks the scripts. Then she might want to make changes. Scratch, scratch, scratch. Page 1, top panel. Inside of a bank robber is behind a counter. There is a bowl of lollipops on the counter. A tiny man is hiding behind the lollipops. He is speaking to the worker. Tiny Man, don't look at me when robbers come in. I want to surprise them. Worker, don't worry. You're so small, they'll never see you. The script goes back and forth between the writer and the editor. The editor may ask the writer to make changes. Great work. Finally, the script is just right. Now it goes to the next person onto the team, the penciler. The penciler is the most important artist on the team. She reads the script carefully, and she can draw the story's pictures with a pencil. Tiny Man, cool. That's the penciler. You can see there, the penciler draws one panel at a time. Seems like a cool job. Now the editor has another job to do. She looks at the pictures and decides they are ready. Sometimes the pictures are perfect. Nice job. Other times the editor will ask for changes. Can you make Tiny Man look more serious? Okay, this is better. Perfect. Finally, each panel is just right, and the panel goes into the next one onto the team to the inker. Step 4, ink and color. The inker is another artist. His job is to draw over the pencil line with a special ink. This makes the drawings darker. The inker also adds details to the pictures. Thanks. Here are the panels for the new tiny comic man. The inker. Let's add some details to this action sequence. The editor checks the inker's work. Very nice. My work is always nice. When the editor is happy, the inker is done. The comic book is ready to move on to the colorist. So far, the drawings are in black and white. The colorist changes this. She uses a computer to add the colors to the picture. The script tells her what colors to use for each item. Blue man for Tiny's clothing, red, green, and purple and yellow for the lollipops. When the colors is done, the comic book goes up to the next person onto the team and to the letterer. Step 5, lettering. The letterer uses the script too. He looks at and sees what goes into the panel. He works on the computers to fill in those words. He fills the words in and tells the characters what he's thinking. He fills the words that tell the character also what they're saying. He fills the words and describes the sound the character is making. So like whoosh. He fills in the names of places, even the numbers on money. The editor checks the panel of each comic. She makes sure that each detail is right. This looks good, guys. You worked really hard. I think Tiny Man #1 is fantastic. Step 6, printing and shipping. The editor sends the comic book to the printer. Big machines print out the pages and staple them together. The comic books are packed into boxes and loaded onto a truck. The comic books are then shipped out to stores everywhere. When people read and enjoy them, something new? What's that? Tiny Man. Tiny Man, who's he? He's awesome. He can go anywhere, even the tiniest places. The comic books team works really hard, as teamwork has really paid off. Try making your own comic. Step 1, think of an idea. Write down what your character is. Think of the story on one page about your character. Writing. Number 2, write a short script to tell a story to what happens. Where's number 3? There's number 3. Drawing. Use a pencil to draw the pictures of your comic. Don't forget to leave the room word for balloons. They will also show what the character is thinking and saying. Ink and color. Draw over your, number 4, draw over your pencil lines and add ink. These details then add on color. And number 5, lettering. Fill in your character's words and thoughts with any other words. Whoosh, you're in trouble now. Printing and shipping. Make copies of your comic, then give them to your friends and family if you had fun making it. Create another one with more panels and pages. Comic strips and comic books. A comic strip is a series of drawings arranged in boxes called panels. These drawings tell a story. It is often a funny story, which is how these drawings got the name comic strips. Comics mean funny. Comic strips started appearing in the newspapers in the late 1800s. Soon comic strips were telling action adventures and mystery stories too. In 1929, a magazine collection of comic strips was published for the first time, and comic books were born. Comic books have changed over the years, but one thing that has stayed the same, they are still popular all over the world. Yeah, so even if you don't like comics and comic books, you can kind of think of some of the characters in popular movies now that are comics. For example, a lot of our superheroes, whether you're a DC or a Marvel person, you know, Batman, Superman, Wonder Woman, or maybe you're more of an Iron Man, Thor, I'm trying to think, Iron Man, Thor, how do I not think, Captain America, if you're that group. So either way, they're all comics. And obviously, you guys have your own comics. I see them hanging on your walls. I'm pretty sure Academia, I think that's the name you guys call it, Academia something. I know Danny has a poster of that hanging up in her room. But yeah, those are all like kind of examples or derivatives of comic books. So pretty cool. Keep reading those comic books. I think those are fun and a great way to become better and stronger readers. Alrighty, so that kind of takes care of our first step, right? And if we look here at our second step, or our first step's reading, our second step is talking about Lexia. Lexia, 40 minutes. You should do Lexia twice a week, 20 minutes a piece, and that gives you a total of 40 minutes a week. Make sure that we're getting our Lexia 40 minutes a week. I really want to try to get a lot of Lexia done, especially before your first Ohio State test, which will be in April, the day after, first day back from spring break. More information will come along with that. I'm not even sure. I know we're going to Willis, but I'm not sure what room. I'm not sure what time. Hopefully they'll give us some more information here soon, and I will get that information to you guys. Scoop Pad. I originally wrote Scoop Pad 30 points, but since Mrs. Hanson on Monday, we talked such a long time. Remember, I cut out Scoop Pad on Monday. So, excuse me, you only need 30 points, 30 points of Scoop Pad this week for ELA. I will still ask you to do 40 points in math because we didn't have a speaker in that class. But 30 points ELA Scoop Pad for the week. because I remember I gave you Monday off. Let's talk about our mini mystery science discussion board post number 22. So what we need to do is go into Canvas, and then we go into here, and then we go into Online Academy 2021, and then we go to discussions. Excuse me. And then we're going to discussion post number 22. Not 23, but 22. There it is, mini mystery science number 22. So I kind of wanted to do something that had to do with, I don't know, leprechauns or something like that, St. Patrick's Day. Best way I come up with our rainbows, because, you know, at the end of the rainbows, a pot of gold, protected by a leprechaun, you know, so on and so forth. That is kind of what I was thinking here. But anyway, so what you need to do is we're going to watch, or you're going to watch this video here. How is a rainbow made? Pretty cool. It's by a kid named Joseph asked that question. And then you guys get to see how a rainbow is made. And then I love his bonus boxes, rainbow art, some of the coolest things in his rainbow art here. And that you answer these questions. Now you can respond to other people's answers. You can come up with your own questions. I'd like to answer those too if I can. But just think of this as a way of me and you and your friends talking, but instead of seeing us face to face on a camera, you can do it behind a keyboard. This is one way to do that. So mini mystery science number 22 is due today. There you go. So I'm having a tough time highlighting that. All right, let's go ahead and go and do our social studies, our reading. So how to get to a reading? We go to Canvas. We open up Canvas and we go into virtual reading. I know by now you guys are like experts at all this, so I don't really have to show you, but it's part of the process, just in case we forget. And then we're going to go to the one that's due on the 19th. After it's loading. And the 19th is called Punctuating Quotes. We talked about quotes earlier this week, and we actually watched a little bit of video about how to punctuate them. But now we're going to go into more detail. What is the best way to punctuate a quote? Who said that? There are plenty of rules in English for showing which part of a sentence is a direct quote. Quotation marks allow you to show which part of your summary is not in your own words, but instead a direct quote from the text. So when we do these science fusion notes, technically we should probably put them in quotes, but between you and me, I understand where it's coming from. Look at these examples. Where do you think the writer needs to add quotation mark? Decide how each example should be punctuated and show the direct quote. So P.T. Barnum thought the acts like Tom Thumb as a living curiosities that audience would love to see in a play. So probably right after where it says as, that should be a quote. Okay, that should be a quote there. And then after curiosities, that's what it's close quote. So open quote, close quote. Why is it called open and close? Because open is the beginning, and then you close it off at the ending. Women who live out in the West often freedom that their Eastern sisters could not have imagined. So right after freedom, that their Eastern sisters could not have imagined, close quote. And if you notice, the period is inside the quote. The period is inside that quote. Calamity Jane was just as famous as Annie Oakley, but had less delicate sensibilities in the way she dressed. So that will be right here, right where it says less delicate sensibilities. So right there, open quote, close quote. So what about commas? Where do we put commas? You'll watch this video to kind of find out the rules for commas. There's a lot of rules for commas. This gets very, very tricky, but we're going to try to keep it as simple as possible.
Rule number 7. You use a comma with quotation marks to separate a direct quote from the rest of the sentence. That means if a quotation comes at the beginning of the sentence, a comma follows it. Or if a quotation comes at the end of the sentence, a comma comes before it. For example, most excellent, said Bill and Ted after their adventure. Notice the comma is placed inside of the quotation marks. Here is another example. I'd rather be sailing, he told his boss. Again, notice the comma is placed inside the quotation marks. Now for an example of a quote at the end of a sentence. She asked, "Does my hair look stupid?" Notice how the comma comes before the quotation, separating the speaker from the words spoken. Here is another example. He replied with a wide-eyed smile. Yes, dear. I mean, no, dear. Whatever you say, dear. Sometimes a quoted sentence is interrupted. In that case, the comma follows the first part of the quote and comes before the second part of the quote. For example, oh, Julie commented, I prefer dogs to cats. Notice the comma is placed inside the quotation marks before the interruption and after the interruption before the rest of the quote. Here's one more example of using a comma with quotation marks. Hey, this guy, Mike told his friends, has commas on his brain.
Trying to be funny, but I guess it's true. Look, commas on the brain. I get it. So, what 3 types of sentences does the video describe? Well, sentences with direct quote at the end, sentences with direct quote at the beginning, and then the only other one is sentences with direct quote in the middle. So, practicing these skills, where should we put this? A or B? So, where should the commas show you to put this? So, hooping today is part art and part exercise, says Hoop Magazine's editor Rachel Bledsoe. Hooping today is part art and part exercise, comma, says Hoops Magazine's Rachel Bledsoe. So if you chose the bottom one, you would have been correct. Where should the quote be, or comma, be here? According to the author of Odd Men Out, comma, the babies appeared at their birth was a shock to everyone. According to the Odd Men Out, the baby's appearance both were shock to everyone. If you chose the top one, you should be right. The noblest art, wrote by P.T. Barnum, is that of making others happy. Or the noblest art, wrote P.T. Barnum, comma, is that making others happy. If you chose the bottom one, oh, I did get it right. I almost missed it. You were correct. Hey, yay, I passed 5th grade. I hope so. Let's see here. So take you guys to your quiz. And there's your quiz. This one's a quick 2-questioner, punctuating quotes quiz. And that'll be due today, by the end of day today. Now, let's go ahead. There you go. Let's go ahead. We need to go and open up food chains and food web. Food chains and food webs. Food chains and food web. So we go into science. And we open up science. And here's your science. Come on. Open up. Open up. And we scroll down. I don't know why that module 1 is always open, even though I have it closed. All the way right to here. There it is. Food chains and food webs. Click. So just a quick before we get started, food chains are unrealistic as food webs are more realistic. A food web is simply just a whole bunch of food chains. Think of your fingers going in straight lines. These are all 10 different food chains, right? These are straight lines. But then once you start interconnecting them and going all kinds of different places, this looks more like a food web. They're going everywhere. Think of a spider web. The feeding relationship between organisms with a population are shown in food chains and food webs. Food web is made up of many food chains occurring in nature. It is a network of food chains or feeding relationships by which energy and nutrients are passed from one species to another. So really, they're passing energy from one place to another. At each time where something eats something else, energy is lost. It's lost as heat. Food webs can be identified in relationships among producers, consumers, and decomposers in an ecosystem. Food web can also tell you about the health of an ecosystem in general. So basically what I said right there, we're going to put to a little bit more pictures to help you out.
The energy needed to sustain life on Earth comes from our nearest star, the Sun. The light that passes through Earth's atmosphere not only warms our planet, but provides producers with vital energy to photosynthesize, producing fuel for Earth's consumers. All organisms within an ecosystem are linked by what they eat. The energy generated by producers from the sun is passed from one organism to the next, as seen in this food chain. In this feeding relationship, the grass is the producer, providing all the energy needed to sustain the other 4 organisms. Grasshoppers are a type of consumer called a primary consumer. Primary consumers are herbivores and eat only plants. The energy obtained by Earth's primary consumers is not equal to the total amount of energy contained in all plant life. Plants have many adaptations that protect most of their tissues from being eaten. Of the plant biomass
cool.
that is consumed, only a small fraction of it is assimilated because eating actually uses energy, especially eating plant matter. Of the total amount of energy available to the grasshoppers, only about 10% of it passes on to move along the food chain. When the grasshoppers are eaten by the frogs, their energy moves along the food chain. In this food chain, the frogs are secondary consumers. Secondary consumers eat primary consumers. When a frog eats a grasshopper, it uses energy to catch, eat, and digest it. There are also parts of the grasshopper that are not digestible. This means that only a fraction of the grasshopper's energy is transferred to the frog. 10% of the energy contained in the primary consumers of this food chain is transferred to the secondary consumers. The movement of energy continues when the frogs are eaten by the snakes. The snakes are the tertiary consumers in this food chain. Although frogs contain plenty of available energy, the snake expends quite a bit to stalk, catch, eat, and digest this meal.
Oh my gosh.
The result is another fractional transfer of energy through the food chain. The energy contained in the snakes is then passed to the eagles. The eagles in this food chain are quaternary consumers. Like all other feeding relationships, there is a good amount of energy expended by the predator to catch and eat his prey. The total amount of energy in all food chains decreases significantly as it transfers. This is why most food chains only have 3 to 4 levels of consumers. Within an ecosystem, all of the organisms are linked by what they eat. Most consumers eat more than one type of food. When many food chains are interconnected, a food web is created. Food webs are delicately balanced feeding relationships. The removal of just one organism can cause a part of an entire ecosystem to collapse.
Crazy.
We must not forget that no matter an organism's level in the food chain or food web, the energy in all living things is eventually broken down by decomposers to become bioavailable once again in the earth. As a member of many overlapping food chains from many ecosystems on Earth, we have the power to affect the health and sustainability of our planet's plant and animal life.
So, what is the longest herbivore on the planet? The longest herbivore is the African bush elephant. Eats only plants, and it weighs, or largest. African elephant bush eats plants, and it weighs to 13,000 pounds. So it's no surprise that our biggest animals in the world eat plants or eat producers. You think about the elephant eats plants, blue whale eats krill or phytoplankton. Why would we assume that? The biggest ones do that is because those are producers. Those have the most energy in them. If you were trying to just live off secondary and tertiary consumers, it's hard to be very big because there's not a lot of energy to go around. So go straight to the source and eat the plants. How many consumers are both primary consumers and secondary consumers? As a result, they might be part on more of one food chain. In that case, they're part of food web. A food web is made up of many food chains occurring in nature. It's a network of food chains or feeding relationships by which energy and nutrients are passed from one species to a living organism to another. This chart demonstrates how our food web works. Excuse me. So you can see here, everything is based off this green plant. You take away this green plant, you start losing what eats it first. We lose the mouse, we lose the rabbit, and we lose the goat. And then we start losing what depends on the mouse, rabbit, and goat. What depends on them because then we start losing the owl and the snake and the wildcat and the jackal, and then the lion. We start losing that because we lost plants. So we have to keep in mind we have to be very careful about the plants that we cut down for whatever reason we use it for. Now, we can't forget about decomposers. The food energy doesn't just disappear, does it? No. You tracked and identified the energy flows upward from producers through more than one layer of consumers. Okay, what happens after that? The food energy doesn't just disappear, does it? No. A food chain or food web is really a circle of transfer of energy. All producers and consumers eventually will die. So I will die and I will be decomposed and returned back into soil. So the energy that's inside me, the nutrients inside me, will be returned back into the soil. A decomposer is an organism such as bacterium or fungus that feeds on and breaks down dead plant and animal matter. They make organic nutrients available to the ecosystem again, and all that goes into the soil. So all that from those worms go to soil. So, pyramids of biomass. This model shows energy flow from the sun down to the decomposers. Biomass is a biological material used for fuel, a source of energy. Here's a model that describes how energy in animals' food web were once energy from the sun. Pyramids of biomass are usually much better at demonstrating the idea of energy loss as you progress down the food chain. This diagram shows the movement of energy through the food chain, showing a pyramid shape. This is an example of biomass as a pyramid of a rocky shore community. Pyramids are the shapes because the energy is lost at each level. Only a fraction of the energy at each level is available to be passed on in the food chain. For example, plants absorb light to make energy by photosynthesis. The bulk of the food is made up of respiration, breathing, right? Respiration is breathing. All the food is lost when the leaves fall in autumn. The only other food stored in a plant at a time is eaten and is available to the herbivore eating it. The herbivore will likely live for a while after eating its meal. It too will get rid of much of the energy absorbed. Only a fraction of the food eaten will be used in making the animal grow. Only this will be available to the carnivore when that herbivore is eaten. So you kind of see here. So first you have your sun. It's your energy input, producers, right? It loses energy through respiration, breathing. Dead remains in feces. That's what decomposers use in production of heat. Primary consumers, again, like a cow is a primary consumer. It loses a lot of its energy by just simply breathing and running its internal organisms in its body. Again, secondary consumers lose energy by breathing. Tertiary consumers lose energy by eating. Their dead remains in feces, also an example of energy leaving their body. Cow poop, right? That's feces. That's leaving their body. That's energy leaving their body. It is broken down by decomposers. And cow poop, yes, it's warm. So what got it warm was inside of their body. So when that heat dissipates and leaves them, they're losing heat, losing energy. So anytime you see something hot, energy is being burnt. Whether it's a stove that's burning a hot water, right? Or boiling hot water, the stove gets hot. Why does it get hot? It's either burning natural gas stove or it's burning electric or using electric to heat it up. Energy is being lost, and in the form of heat. Sorry, I don't know why I paused there, but in the form of heat. Alrighty, so that is the first half of our class. Lexia, give me those 40 minutes. AL quotes, punctuating quotes quiz. Screw pad, actually 30 points because we did not do Monday. Food chains and food webs quiz, and then a mini mystery science about rainbows. Excuse me. I need a drink of water, but I don't have any nearby, so I'll have to fake drink. Go, 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 go. All right, so we're going to go in, and we're going to do our brain pop, and this one is going to be about Marie Curie. And let me see if I can get that pulled up for you guys. Clever. Log in. Log in. Did log in like 3 times just to get to this one thing. Log in. Loading. Marie Curie. I feel like did I do this one yet? I think I did. Maybe I wrote the wrong thing. Maybe I did it. I can't remember now.
That's where my arm got broken last year. Oh, stop apologizing. I know it was an accident.
Ooh.
Dear Tim and Moby, who invented radioactivity? From the Sufficer. Well, actually, nobody invented radioactivity. It's a natural property of certain elements. But the word radioactivity was invented by one of its early researchers, Madame Marie Curie. Radioactivity is when atoms shoot out high-energy particles or waves. It happens when the nucleus of the atom partially disintegrates or falls apart. As the atom decays, the number of protons and neutrons in its nucleus change. In other words, it turns into a completely different atom with different properties. In the late 19th century, scientists knew that certain substances gave off mysterious rays. Marie Curie was the first to propose that radioactivity is caused by something happening inside the atoms of radioactive elements. She was born Maria Skłodowska in Warsaw, Poland in 1867. Maria was interested in science from a very early age. But because she was a woman, and because she was Polish, she could not get admitted to any university. Well, Poland was part of the Russian Empire at the time, and there was a lot of prejudice against Poles. So Maria traveled to Paris to study physics at the prestigious Sorbonne University, eventually becoming the first female professor there. She changed her name to the more French-sounding Marie, and married Pierre Curie, a physics professor at the Sorbonne. In 1896, the Curies began to experiment with uranium, which was known to emit a mysterious sort of energy. Marie made a few important discoveries. First, she figured out that minerals with a high amount of uranium in them emitted more intense rays than minerals with a small amount of uranium. Marie began to think that uranium atoms might be changing on the inside. This was unheard of at the time. Most scientists thought that atoms were unchanging objects from the beginning of time. When Marie saw that the element thorium gave off a similar energy to uranium, she named the property of energy emission radioactivity, a term based on the Latin word for ray. No, you can't just go and buy uranium. The Curies extracted it from a mineral called pitchblende, which brings us to another of Marie's discoveries. She found that the pitchblende gave off more radiation than the uranium she extracted from it. She suspected that there were other elements in pitchblende that were even more radioactive than uranium. With Pierre's help, she refined the pitchblende to figure out the source of the mysterious radiation and came across two new elements. She named them polonium, after her home country of Poland, and radium, after the element's radioactive properties. Yeah, in 1903, the Curies and Henri Becquerel, the original discoverer of radioactivity, shared the Nobel Prize in Physics. And Marie won the Nobel Prize in Chemistry in 1911 for her discovery of polonium and radium. The discovery of radioactivity was immediately recognized as useful to science and technology. It led to everything from medical x-rays to time-measuring techniques to glow-in-the-dark watches to nuclear power. But people didn't realize early on how deadly radiation could be. Yeah, in 1934, Marie Curie died of a blood disease that can be caused by radiation poisoning. No, I don't think I'm going to get sick from one x-ray. You worry too much.
So when you guys go to the dentist, they take pictures, you got to stay in there, they put a little something in your mouth. You stand like this, and a little thing comes over, and it comes next to your jaw, and they go, okay, 3, 2, 1, and then you turn, put the thing on the other side, you go, all right, 3, 2, 1, They also tell you to put this like big, heavy, weighted vest on. And you think to yourself, well, why do they even have us do this? Next time you're a dentist, ask them why they do that. The vest should be made of a metal called lead. And when they're shooting, they go, they're shooting radioactivity waves into you. So that way they can see what your jaw looks like and your teeth look like and so on and so forth. And the radioactive vest is there to protect you as much as you can because you're getting it right here and here. And I think they do one right here too. I can't remember. But they're trying to protect the rest of your body with using a lead vest. That lead vest stops the radioactivity. If only Marie Curie knew that at the time, she wouldn't have died so soon and suddenly of radioactive poisoning. But yeah, next time you're in a dentist, just ask them. The dentist tech or whoever's doing it will know more about it than I would. All right, so SCOOPAD, 40 points. This is different than the morning class. I want 40 points of math. We didn't have anything missing in math this week. So let's go ahead and do weather. Yeah, what? Weather? Yes, weather. Because we've been talking about maps. Group tabs together, right? Okay, whatever. I don't know what that means. Okay, got it. That's what I'm going to hit. We've been talking about maps and social studies, so let's talk about weather maps. Yeah, we could probably tie this into science, but we're going to call this just maps for weather. And come on, come on, come on, come on, come on. Where did you go? There it is. There it is. Excuse me. Places on Earth. Oh, too far. Trek to different places around the world and experience a variety of climates and regions, and learn about the characteristics of grasslands, deserts, polar regions, tundras, forests, and many more. So in this video, I'm just going to talk to you guys about those different regions. Sorry, AirPods weren't turned off. Whoa.
Geographers are scientists who study the Earth's landscapes, its oceans, and atmosphere. They study plants, animals, and people too. Geographers use certain names or terms to describe places on Earth that are the same. In this program, we'll learn terms to describe different places on the Earth.
Well, hard practice.
You know, scientists have determined that some places on Earth have a particular kind of weather pattern called a climate. Weather, climate, and geography working together cause some places on Earth to be hot, while other places are very cold. And while some places on Earth are dry, other places are wet. Scientists have developed several geographic terms to describe these various areas of the world. The first term we're going to learn is grasslands. Grasslands are large, wide-open spaces covered with grasses. Savannas are grasslands that are found in tropical and subtropical climates, not far from the equator. There aren't many trees in most grasslands because there isn't enough rainfall for them to live. But there are all kinds of animals. Elephants and antelope live on African grasslands. Prairie dogs and buffalo live on grasslands in North America. And kangaroos live on the grasslands of Australia. Grasslands are found in North America, South America, Africa, Europe, Asia, and Australia. Some places on Earth are so dry that even grasses can't grow there. These places are called deserts. When you hear the word desert, you may picture a very hot land filled with piles and piles of sand. But there are also cold, dry deserts too, like the Gobi Desert in Asia. In the desert, you'll find different kinds of plants and animals who have adapted and are able to live in the desert. Deserts are found in North America, parts of South America, Africa, Asia, and Australia. The coldest places on Earth are the polar regions. You'll find the poles at either end of the Earth's axis. Axis is the name we give to the imaginary line that goes through the middle of the Earth. The North Pole is at the northern end of the axis. It's located in the middle of the Arctic Ocean, surrounded by ice and snow, and is always frozen. The South Pole is at the southern end of the axis. The South Pole is on land, on the continent of Antarctica. It's always surrounded by snow and ice because it is so cold. As you move away from the polar regions, you'll enter another region of the world that is cold and barren. It's called the tundra. The word tundra comes from a Finnish word, which means barren land. Tundras were considered barren because there were no trees. But in the summer, it does get warm enough for mosses and a few wild flowers to grow. There are tundras in North America, Antarctica, Greenland, Europe, and Northern Asia. Next, let's explore the forest regions of the Earth. There are different kinds of forests. The first type of forest is a coniferous forest. A coniferous forest has trees with needle-shaped leaves and cones like pine, fir, and spruce. And because they stay green all year, the trees are also known as evergreens. Coniferous forests are found in the northern regions of the world, on the North American continent, parts of northern Europe, and northern Asia. Another kind of forest is called the temperate forest. Temperate forests are found where the climate is between hot and cold, and where there are 4 seasons: spring, summer, autumn, and winter. In a temperate forest, you'll find trees with broad leaves like maple or oak trees. These are the trees that drop their leaves in the fall, called deciduous trees. Some temperate forests also have coniferous trees mixed in. Many kinds of animals live in temperate forests. Temperate forests are found in North America, South America, Europe, Africa, Asia, and Australia too. The third type of forest geographers refer to is the rainforest. Tropical rainforests only exist in very warm climates with lots of rain. The plants and animals that live in the rainforest have all adapted to the heavy rainfall and excessive heat. Tropical rainforest plants have very broad leaves and trees that grow tall above the dead shrubs and vines. A very dense rainforest is sometimes called a jungle. Tropical rainforests are found in South America, Africa, Malaysia, and Australia. There are also temperate rainforests. Temperate rainforests are made up of evergreen
That's what we
coniferous
live in.
trees.
Columbus.
There are also
Delaware.
broadleaf deciduous trees. Animals that live in the temperate rainforests include black bears, river otters, and more. Temperate rainforests are found in North America, South America,
Or like right
parts of
here,
Europe,
kind of by the
Asia,
A,
and Australia.
right where that forest is.
Those are some of the terms you need to know to locate and describe places all over the world. Now let's play Know Your Geography. See how much you remember. Here's the first question. Number 1. The coldest places on Earth are located in the A. Polar regions, B. Coniferous forests, C.
What do you
River
think?
valleys, D. Equator region.
Yeah, equator.
The correct answer is A. The coldest places on Earth are located in the polar regions. Question 2. What is the name of the imaginary line that goes through the middle of the Earth? A. Core, B. Center line,
Yeah.
C. Axis, D. Goal line.
Yeah.
The correct answer is C. Axis. Axis is the name of the imaginary line that goes through the middle of the Earth. Question number 3. The driest places on Earth are called A. Islands, B. Deserts, C. Rivers, D.
Rivers,
Rainforests.
water. Come on.
The correct answer is B. The driest places on Earth are called deserts.
Desserts.
Thanks for playing
Desert.
Know Your Geography.
I always like to say call them desserts, even though they're deserts. All right, so what did you know about America's land? Geography is the study of physical Earth and the way it affects human, plant, animal life. Climate is the pattern of weather over time. This also affects human, plant, and animal life. So we got to make sure we understand that weather is like what's happening right now. Climate is what's happened over hundreds of years. So much different. Weather versus climate. Climate, hundreds, thousands of years. Sometimes millions of years would be a climate. Weather was what's happening now. What's happening 3 days from now. You know, what's in the 5-day forecast. That's weather, okay? Climate is much different. Climate will not change in our lifetime. It takes a long time to change it. It's a whole bunch of events that lead up to changes. Your trip. Think about what you need to travel from coast to coast. Imagine you're preparing a trip from around the U.S. There are certain things you'll need to know, such as what to bring and what to pack. Both of these things are affected by geography, and climate. Knowing the general climate of an area can help you predict the weather for any given day. For example, if you're planning to travel to Minnesota and you knew that'd be a very cold winter time, you might plan to go through there in a warmer season and pack lots of warm clothes. Knowing that many parts of Arizona have a hot climate, you might plan your trip in one of the cooler months of the year. So what's the difference between weather and climate anyway? Well, weather happens over a short period of time, climate thousands of years. So check the weather. How is it where we live? Climate is a pattern of weather over a time. A place that doesn't give much rain over a period of years is said to have a dry climate, while somewhere that gets a lot of rain is considered to be a wet climate. For example, as mentioned before, the climate in Minnesota is very cold, but that doesn't mean the weather on any particular day must be cold. It is possible to have warm and sunny days in the north, although there are fewer of them than there is in the south. You can find excellent weather information on the internet. You can also look at current weather anywhere in the world. You can get forecasts and the future information about hurricanes and learn more about weather and patterns. On the weather information sites, all you need to do is type in your zip code and see what's happening in your area right now. So one of those easy ones that we go to is just go to weather.com. And if you go into weather.com, we can see there's tornadoes breaking out here. It looks like this is Louisiana, so this is Arkansas. Louisiana, Arkansas. So this area, general area here, we're having a little bit of tornadoes. And if you want to buy some clothes from Russell LeQuinn, you can buy clothes there too. No way those shoes actually stay like that. It doesn't even get dirty in 2 seconds. But anyway, if you type in the zip code 43209, which is where I live, 43209, Columbus, Ohio, you can see right now it's 8 o'clock. It's almost 60 degrees. Rain is moving in to Columbus tonight. And, it gives you kind of all the weather that happens there. Oh, man, I want to see what's going to happen over the next 10 days. So I can click 10 days. I can see, well, it's going to get down to 52 degrees. Thursday, high 54, a little rain, pretty windy. Friday, high 47, again, very windy. Saturday, 56, really nice day. Sunday, 62, 65. Dang, next Tuesday, 68, 69. We're almost into 70-degree weather. And then we go on spring break, and it gets cold again. Hey, what can you do, right? So our spring break starts right, I guess this is our spring break last day, so spring break first day, 56, 57, 59. It's not exactly cold, but it's not exactly like, 68, 69 warm, but nonetheless, still pretty good. Let's go on to our next one. So Groundhog Day began many years ago. People used to create stories explaining weather today. Today, scientists and meteorologists study temperature, air pressure, and other factors to predict upcoming weather. Here is what Groundhog Day is. Or kind of a funny thing of Groundhog Day.
At the Punxsutawney Weather Discovery Center, visitors can learn about both tales and facts. One fact they often learn is that the first official Groundhog Day in the town was celebrated in 1886 and has been observed there every year since then, to this very day. Visitors at the center can learn many things about the weather and weather forecasting too. They can learn what it's like to be a weather forecaster on TV. They can create a storm, one with wind, thunder, and lightning. And they can learn about tornadoes, including the direction in which those violent twisters turn. They can also find out about weather symbols, as well as the water cycle, in which precipitation, rain, snow, sleet, and hail falls to the earth from the sky, flows into rivers, ponds, lakes, seas, and oceans, moves back into the sky in a process called evaporation, and then falls back to Earth to begin the process once again. Weather scientists, they're called meteorologists, know a great deal about the weather today because they use computers, satellites, and a number of other advanced devices. So today, we don't use old wives' tales, such as when the cows stand tall, no rain will fall, to predict the weather. Even so, it's still fun to celebrate Groundhog Day, especially if you're in Punxsutawney. There, You can join thousands upon thousands of
Like, this is a
celebrants
real
at
thing,
the
guys.
College
People
Valley
really do this.
early in the morning, before sunrise. Dancers entertain the audience while everyone waits for Phil to make his appearance. There are
The
also
big fat
speeches
groundhog.
and a giant fireworks program. Right after sunrise, Phil makes his appearance, and his prediction is
The
announced.
sky shines bright above me. My shadow I see beside me. 6 more weeks of winter it will be.
Some people aren't too happy with Phil's prediction.
Uh,
Others are very happy about it.
I couldn't be happier. I love winter. Good weather for ice skating and going skiing. This is great.
Happy or not, after the ceremony, people pose for snapshots, take pictures, and get a closer look at the fuzzy animal. And everyone seems to agree that
Has anybody ever been to Punxsutawney, Pennsylvania and seen Punxsutawney Phil? I think that would be pretty cool to see if you could make a trip out there. So anyway, that takes you guys to your weather quiz. This is a 3-point weather quiz. And last but not least is math, graphing on a coordinate plane lesson exam. Dun, dun, dun. So we'll go ahead and go into our math. Opening it up. Opening up math. Opening up math. 3 plus 2 is still 5. Good job. And open. Sesame. And then we'll go on down to, whoa, hey, jumps around a lot. Graphing figures exam. We've been working on graphing a lot this week. Here is your guys' quiz. Ooh, my arm kind of hurts. Whoa, I hit the wrong button. Sorry, I hit edit. We're not editing the quiz. Come on, Mr. Dooley, we were previewing the quiz. Sorry, when I edit the quiz, it means I'm making the quiz. Alrighty, so remember the points. Let's see here. Maybe I can do this. So let me see here. I can go open up this. I need something to write with, so I have to go into Cisco WebEx. Don't worry, guys. No one's going to be jumping on here. I have to hit start the meeting. My picture probably gets blurred out when I do that. Okay, maybe not. All right. And then if I hit share, that gives me access to this annotating figure. Okay, let's do a different color. Let's go red. So again, we're going to identify the shape from the points 5, 5-0, 5-1, 6-0, and 6-1. Okay, so we look, well, did they already do that for us? Okay, so identify the shape. Okay. Really? That seems like a no-brainer there. So what is that right there? Triangle, square, parallelogram, or rectangle? Don't overthink that one. Don't overthink it. This one right here, this one's a little bit harder, okay, because it has a, come on, let me draw, let me get out of the way, let me draw. We're going to go there, there, to there, to there. Which one of these shapes is that? Okay, and going on, okay, we connect these, which shape is that? And let me see here, we're going to find the missing coordinates to figure out the shape of a rectangle. Okay, so I can give you a hint here, a very strong hint. If we go drop this down, we line up right here, we finally have our rectangle. What point is that right there? Okay, remember, first thing you need to do to get the first number here, if we're finding first number, you have to find how far over it went. What counts? How far over it went. Okay, then we take that first number. I'm going to call that number X. And then we need to find our second number. Let's get a different color in red. Let's go green. And we go up from here. And whatever that is, how many of these we went up, we'll call that Y. And there's your number. Whatever that matches up to down here is your answer. One of these ones right here. Okay? And scrolling, same concept here. We're going to make a square. It would be right there. What is that point? Find the area of figure 1. Well, you simply just count 1, 2, how many are there? Of area number 1, it's just this area right here, that little rectangle. find the area of 2. It becomes a little bit more difficult, but we count these guys in here. How many of them, okay, are there in figure 3? How many are there in figure 3? Just count those blocks. In figure 4, same concept. And number 10, the following figure needs to be a rectangle. It should be 20 units. In order for this to be true, there are 2 missing points. Where are the 2 missing points if this needs to be 20 cubes? Okay, this 20, oh, I don't want to give away the answer. 20 cubes. Are the 2 points 5.0 and 510? True or false? And that's that. And that's your graphing figures exam. Bam. Alright, just to recap everything so that we're all here and all on the same page, I'm actually going to shut this down so that way, oh, duh, it's up there. So let me shut this down real quick because that just slows everything up. Okay, sorry, end meeting, yeah, no one's supposed to be on that meeting. Okay, I'll hit update just because I want to update it. Speaking of updates, you'll be getting an alert and update about your Chromebook here soon. Go ahead and update it. It should only take a minute or so to update it. You might have to restart your computer to find that update. It's important to do that update because you'll need that for your testing, Ohio State testing, which will be, what is that, beginning of April when we get back from spring break. Well, anyway, I'm rambling on here, but what should we be doing? Make sure that you guys are doing 40 minutes of Lexia, that you're getting your AL punctuating quotes and quiz, that you're 30 minutes of ELA scoop pad, your AL for food change and food webs, and your mini mystery science number 22. So mini mystery science number 22, that's your punctuating quotes and quiz, that you're getting your food change and food webs completed, that you're getting your weather quiz completed, and that you're getting your graph and figures exam completed, and also make sure you're getting your scoop pad math completed, 40 points. Alrighty, I will be meeting with a few of you guys this week. If you have any missing work in AL, make sure you get that done. Don't fall behind. This is your last quarter. You won't have, it will be the last day of school. You won't have any time to do any missing work. So make sure to get your work done as quickly as you can. If you want to meet, let me know. I know I'm meeting with a few of you guys today, so just let me know. Alrighty, I will see you guys later. Bye.